Hi, this is John Regier, and this is the fourth video for week one of CS 1030. There's a really important thing that happens when we write computer programs, which is called functional abstraction. And it's kind of a big phrase, but it's really easy. So the idea is we can take the code that does something, some task, maybe draw a square on a screen, maybe sort a list of names. It doesn't matter what it is, and we can put it into what's called a function. So a function is a piece of computer code that can be called independently, and you don't need to understand how it does its job in order to use it. So it's really, really, really important that you don't have to care about the details of interacting with, for example, the video board on your computer. If you just want to draw a square, you call the function to draw a square, and you don't understand, you don't have to understand all of these details. So in functional abstraction, there's always a caller. That's the code that calls a function. And then there's the callee. That's the function that's called that does some sort of a job, like, again, drawing the square. So sometimes you'll be writing only the caller code, in which case you truly don't have to understand how the callee does its job. But other times you'll be writing both the caller and the callee. And in this case, you do understand how the callee does its work, but you can think about it separately when you implement the callee. And then when you're writing the caller, you could only have to think about that. So even if you're writing both sides of this, even if you're writing both the caller and the callee, functional abstraction saves you an enormous amount of complexity when you're trying to think about a programming problem. So let's look at an example. So here is a function in the C programming language. So C is the programming language used to implement things like operating system kernels typically. And what this does is moves memory from one part of the computer memory to a different part of computer memory, or sorry, moves data from one part of computer memory to a different part. And you don't need to understand what this does. If you think this looks gross, then that's great. And so remember, the idea behind functional abstraction is if somebody else writes this memory copy function, you can just call it. You don't have to care about the gross details because somebody else took care of it. And things can be a lot worse than this C code. So C is generally a programming language in which you can write code that runs pretty fast. But if you want to write code that runs really fast, then you write it in the very lowest level, assembly language, which we'll be looking at a different version of in a later part of this course. So here's a memory copy function that's used on an Android phone. So if you have an Android phone, you're running this code. And some human wrote this assembly language to do the memory copy. And this is only a small part of it. It's a really complicated function. And you wouldn't think that copying memory is that hard. And it's not. But it turns out that it is if you want to do it really, really fast. And for whatever reason, computers spend a lot of time copying data from one part of their memory to another. They spend, tons and tons of time. So if you want to make a phone fast, making the memcopy, the memory copy function fast, is a good place to start. So anyway, so the point of this is not that you should understand anything that's on this slide, but rather that somebody whose job it is to understand this wrote it. They did a really good job at it. And you, as the caller, only need to call it. You don't have to understand anything about how it actually does its job. And this is, again, just really fundamental. It's really, functional abstraction is really one of the key reasons that we can program computers at all. Because what it does is allows us to only think about the details of part of a problem at a time. If we tried to understand all parts of a word processor or something like that at a time, we'd never be able to implement Microsoft Word or Microsoft Excel or some of these other large programs, or maybe something like a web browser. But since we can use functional abstraction to break up a big job into small parts, human beings with our sort of small brains or our sort of limited brains can actually do these incredibly complicated jobs. So this is almost the most fundamental skill involved in computer programming. It's something that I'm going to spend a lot of time kind of harping on over and over throughout this course, and it's something you'll hear about from other instructors through the rest of your time as a computer science major, and it's something that we're really going to need you to understand.